now let's look at the conservation of momentum in practice. Okay, so we'll start off with just one dimension motion, and we'll answer the first question of if I drop a mass, hit the floor, bounce back up with here the speed is 5 meters per second downwards. Okay, so if I'm in one dimension, this better be I better use plus and minus to signify. So I'm going to use the standard positive as pointing up. X or Y either way, it's 1D. I don't need to worry about that. So -5, and ask what is V over here. Okay, so here there's a couple of ways you can go about it. You can at first you might think, can I use SUVAT? Now from this process to this process, did it accelerate? Did the acceleration change? Now from here to here, the acceleration is pointing towards the ground with free fall. All right, so the acceleration is g or minus g. Here is minus g. However, over here, there's a big extra force, right? There's a huge contact force the moment it hits the ground and bounce up. It's a huge normal force pushing it up. So when there's a force, there's extra acceleration. So the acceleration changes. So in principle, you're not allowed to use SUVAT or kinematics equations because those are for constant acceleration. Acceleration is not constant. It's constant everywhere except for this point, right? The point of hitting here, there's suddenly a huge acceleration upwards. Or originally the acceleration is downwards for free fall, but here suddenly there's a huge acceleration upward and changing the velocity from this way to this way. Okay, so you cannot use kinematics equation, even though one of them actually just by coincidence actually work, but it's a coincidence, it's not the appropriate way to use it. So we should do conservation of energy because we learned the force approach and the energy approach. All right, so before, what is the energy before? Well, what is in my system? I have a ball and I have a floor. Okay, so initially the kinetic energy, let's just use K just to save up some ink. So K initial of the ball plus K initial of the floor, right? What else? Gravitational potential energy, all right? So U initial of the ball. Okay. And we'll set that height as 0 over here, and that's it. Okay, so obviously the floor is not moving as well, and initially it's at some height. Okay, mgh. Okay, that's fine. And we'll have final of the ball plus final kinetic energy of the floor, and plus the U final of the ball, like that. Of course, the floor is not moving throughout. Now, so this is 0, but also the U's cancel out because it's mgh. But I'm asking when it goes back to the same height. If it's not going to the same height, then these don't cancel and we'll have a different value. Okay, but if they do get back to the same height, then this will equals to this, right? They are the same number, so you can just subtract 1 over to the other side, and you will cancel that. Now that means what am I left with? That's half mu square. Mass of what? Mass of the floor? No, mass of the ball, right? That's why we put the labels here. Mass of the ball. Yeah, I won't put the label here because now you need to understand it if you're asked. But yeah, and also when you're doing your equations, make sure you're clear what each variable means. What is U? The velocity, the initial velocity of the floor? No, the ball, right? Okay, so because everything's from here, make sure you understand where the variables come from. And this is half mv squared. I repeated myself with m, right? Warning sign should come up. Is that the same m? So final and initial, yes, it's the same m. Okay, so if you're convinced, that's fine. Right, so now you can divide both sides. The 2 will cancel as well. So u squared equals v squared. So u equals to v. Right? No. When you take square root, u can be plus or minus v. Right? So this equation, u can be v, obviously then it will satisfy, or u can be minus v, and still this will satisfy, right? Because if u is minus v squared is the same as v squared. So make sure you have 2 answers, or v is minus u, either way. Okay. Now you're gonna pick. Okay. What is my aim? My aim is to find v. So v is also, in case you're wondering how to deal with this, if you technically you can just multiply both sides by -1. Okay. So multiply multiply both sides by minus plus, and you can, multiply both sides by plus and minus. So just to show you this rigorously, so you multiply plus and minus to this. Plus times plus is plus, minus times minus is also plus. So you have v equals to plus and minus u. Okay, this is a trick you can go about it. Now, if you think that this trick is too sneaky, what this really means is u equals to positive v or u equals to minus v. Okay, what that means, if u equals to positive v, that means v is equals to positive u, right? That's u equals v, v equals u. But this means that v equals to negative u. So if I recombine them, so if I split this off, that's what it really means. If I recombine them, then v is plus or minus u. I get the same conclusion. So this is just this is not proper math. It's just a trick. Well, it is proper math because it's rigorous, but it smells more like a trick. But yeah, anyway, it's a long way of saying v is plus or minus u. Why do I have to do that? Because my aim is v. So I could have just swapped this and just jump right to here right away. But anyway, just to show you some tricks. Which one should you choose, right? Well, u is minus 5, right? So it's either plus minus 5 or minus minus 5. Which one should I choose for v? Well, from the physics, looking at the picture, this has to go up. So it should be positive. So I need to choose v is minus u. Okay. And reject v equals to u. Okay. So make sure you understand you need to do that. The math doesn't tell you the whole story. You need to use your brain a little bit sometimes to reject some nonsensical math answer, because if you have squares, you need to able to math is just a tool, right? You need to actually be able to use the tool and not let the tool do the rest, do all the work for you. Okay, so yeah, that answers what that velocity is. It is actually the same velocity. Okay,